In this session, we're going to explore recursively defined sequences. And a recursively defined sequence can be characterized as a sequence whose terms depend on previous terms. These are typically expressed as a sub n, my nth term, is, I don't know, for example, 3 plus a sub n minus 1. Where whatever the term you're trying to get is, you have to know the term that came before it. Here's the thing. You need not only the rule for the sequence, but you also need a starting point. You need to be told that, for instance, a sub 1 is equal to 5. If a sub 1 is 5, and I have this rule here, then a sub 2 is going to be 3 plus a sub 2 minus 1, so a sub 1. That's where I plug in the 5. So I can say it's 8. For a sub 3, I'm going to use the 3 from the rule, but then if n is 3, then n minus 1 is going to be 3 minus 1. So in that sense, it depends on knowing the previous terms, in this case a sub 2, which is 8, and this would give me 11. So this is what a recursively defined sequence is. In our first example, we're asked to find the first 5 terms of the recursively defined sequence that has its first term of 1, a sub 1 equals 1, and a sub n is equal to 1 over 1 plus a sub n minus 1. So a sub 2 will be 1 over 1 plus a sub 2 minus 1. So it's still a sequence. It still has whole numbers as inputs, positive whole numbers, that is, natural numbers. But in this case, the n is, we're playing with indices. We're playing with the subscripts there. So if a sub 2 is 1 over 1 plus a sub 2 minus 1, that means it's 1 over 1 plus a sub 1. A sub 1 we were given, so that's why you have to have a starting point. So a sub 2 is equal to 1 over 1 plus 1. In other words, a sub 2 is 1/2. A sub 3 is going to be 1 over 1 plus the previous term, a sub 2. Again, a sub n depends on a sub n minus 1, the previous term. So in this case, that's going to be 1 over 1 plus 1/2, because that's a sub 2. And that means we're looking at 1 over 3/2, which gives me 2/3. I don't get to skip ahead to like a sub 10 for something like this. I have to know the previous term before I can generate a new term. A sub 4 is going to be 1 over 1 plus a sub 4 minus 1, so a sub 3, which is 1 over 1 plus a sub 3 is 2/3. So this is going to be 1 over 5/3. Just do the math there quickly, hopefully. And the answer is 3/5. A sub 5 depends on knowing a sub 4. In this case, 1 over 1 plus a sub 4, so 1 over 1 plus 3/5. That's going to be 1 over 8/5. The answer there is going to be 5/8. Well, this is kind of all over the place. So the first 5 terms we can write down are going to be 1, that was given to us. Let's scroll up here. A sub 1 was given to us. Don't forget that. That is the first term. A sub 2 we found to be 1/2. So 1, 1/2. A sub 3 was 2/3. So 1, 1/2, 2/3. And then a sub 4 is 3/5. A sub 5 is 5/8. And those are the first 5 terms of this recursively defined sequence. Next, we have another recursively defined sequence. We're again asked to find the first 5 terms. We're actually going to go beyond that because this one's kind of interesting. A sub n is equal to a sub n minus 1 plus a sub n minus 2. Let's see what this means in normal people talk. The term I'm looking for is the previous term added to the term before it. Okay, so I have a sub 1 is 1 and a sub 2 is 1. I need at least that information to get started. So a sub 3 is going to be a sub 3 minus 1. You see n is 3 plus a sub 3 minus 2. And if you simplify those indices, you get a sub 3 is equal to a sub 2 plus a sub 1. Or in this case, 1 plus 1. So a sub 3 is equal to 2. A sub 4 is equal to a sub 4 minus 1 plus a sub 4 minus 2 if you like. But if you're kind of catching on to the pattern here, you can see that a sub 4 is really a sub 3, the previous entry, or previous term, plus a sub 2, the term before it. In this case, that means a sub 3, which is 2, plus a sub 2, which was given to be 1. So a sub 4 is equal to 3. A sub 5 is equal to a sub 4 plus a sub 3. Right? The fifth term depends on knowing the fourth term and the third term. That's what it means to be recursively defined. A sub 4 is 3. A sub 3 is 2. So a sub 5 is equal to 5. Well, write down the first 5 terms means what this. 1, 1. Those were the first and second terms. The third term we found was 2. The fourth term we found was 3. The fifth term we found was 5. Now that's the answer to the question, but let's explore this just a little bit further. The third term is the sum of the first and second terms. The fourth term is the sum of the second and third terms. Remember, we said each term is what happens when you add up the 2 previous terms. Knowing that, we can say this sequence is 1, 1, and then 1 and 1 make 2, 1 and 2 make 3, 2 and 3 add up to 5, 3 and 5 add up to 8, 13, 21, 34, and I'm going to put ... This is an interesting sequence. It's known as the Fibonacci sequence. If we take ratios of entries, like 3 and 5, if we look at 5 over 3, or the next one, the next pair, 8 over 5, or the next one, 13 over 8. This is a sequence in and of itself. And these fractions get closer and closer to what's known as the golden ratio. And just so you can see some of why some people think math is interesting, I encourage you to do an internet search of the Fibonacci sequence and the golden ratio, just for fun. Anyway, the answer to this question, 1, 1, 2, 3, 5, are the first 5 terms of this recursively defined sequence. And this session wouldn't be complete without trying to figure out a formula, so here we are asked to find a recursion formula for the sequence 4, -1, 1/4, -1/16, ... In other words, we're supposed to come up with a formula that depends on previous terms. So what I need is a sub n is equal to, and we need to figure out a rule that depends on previous terms, and we can't neglect to write down that a sub 1 is equal to 4, right? That's the first term of the sequence. We need at least that much. Okay, so if I start with 4, how do I get to -1? I could subtract 5, but then to get from -1 to 1/4, subtracting 5 doesn't work again. So we need a pattern that works for all of these guys. So it's not that. How else can I get from 4 to -1? Suppose I divide by 4 and make it negative. 4 divided by negative 4 gives me negative 1. Okay, that's cool. Does the same rule work to get me from negative 1 to 1/4? Negative 1 divided by negative 4 does indeed give me 1/4. And then a quick mental check tells me if I take that 1/4 and divide it by negative 4, I get negative 1/16. So it seems the rule is dividing by negative 4. Now remember, we're looking for a recursively defined sequence. So I need a rule that depends on previous terms. So a sub 2, in this case, which was negative 1, was achieved by taking 4 and dividing it by negative 4, right? This 4 right here was our first term. That was a sub 1. As we just verified, also, the third term, a sub 3, which is 1/4, is what happened when we took negative 1 and divided it by negative 4. And in this vernacular, negative 1 was equal to a sub 2. So I can see that the subscripts are off by 1, just like I want them to be, because for a recursively defined sequence, we need to write something down that depends on previous terms. So I think I'm going to say that a sub n is what happens when I take the previous term, a sub n minus 1, and divide it by negative 4. Math people typically don't like to see a negative in a denominator, so I'm actually going to write this down as a sub n is equal to negative a sub n minus 1 divided by 4, and we can't forget that we have to give a starting point. In this case, a sub 1 was equal to 4. So this is a recursive formula for the sequence that was given.